and using some of the engine's power, you can actually reduce the drag on the aircraft, and you end up then with a low pressure area on the aft portion of the fuselage, which offsets some of the high pressure on the nose of the fuselage. And that offset means that you can move through the air more easily because the total drag has been reduced. And you're not the propulsion, part of it's being used to push back and move you through the air, and part of it's being used to reduce the total drag, which allows you to then make your thrust much more efficient. Kind of interesting approach. So what does that all mean? Next slide, please. If we put all of those pieces together, whoops, sorry. The last is boundary layer control, and that's kind of what we see in an air hockey table. You're creating a little layer of air across the top of the table, which allows that puck to slide without friction or very, very low friction. By doing the same thing and controlling the boundary layer and keeping a layer of air close to the wing that is non-turbulent, we allow the rest of the air to slide over the aircraft much more easily, and again, reducing the drag. So if you put all of those pieces together, next slide, you end up with a very unique geometry. And that design of the aircraft incorporates all of those attributes that I've just discussed. It turns out that the airframe itself, unrelated to the propulsion system, just the airframe itself is 30 to 50% more efficient. So now you put a more efficient propulsion system in it, a nice hydrogen fuel cell or hydrogen combustion, could be battery electric, could be some kind of a hybrid electric. Whatever you decide to put in that airframe, you end up with much greater efficiency, and you're using much less hydrogen, much less electricity, because the airframe itself is more efficient. It turns out that you also are able to carry more payload because you're generating more lift. The effective span length of our 32-foot wingspan aircraft is actually 49 feet. So it feels like there's a 49-foot wing out there allowing us to get more lift and carry more payload, even though the wing is only 32 feet long. By putting the propulsion system at the aft of the aircraft, we don't have all of that turbulence over the nose, and that creates noise inside the aircraft. By using better muffling and other baffles and controlling how we exhaust the spent fuel, in the case of combustion, it turns out to be much quieter as well. And we have a smaller prop, more like a fan. And so a fan doesn't have the tips as close to the speed of sound where you get a lot of the noise in a conventional aircraft. Again, we talked about the fuselage. By using a different shape, which is more optimal for moving through the air, you have much more room inside. And as I said, it's propulsion agnostic. So we are thrilled to work with people that are developing other types of propulsion systems